Hi, this is Nusra Jahan from group number 47. Today we are presenting our analysis on bat and rat behavior to explore how rats may influence bat foraging patterns. So here, in our first cell, we import the tools we need. Pandas and NumPy help us work with data. Matplotlib and Seaborn make our plots look nice, and SciPy runs our statistical test. We also set a standard size for our plots to keep them clear. Let me run this cell to load everything. In this cell, we load our two datasets. Dataset 1 has information about bat landings, like how long they hesitate before getting food. Dataset 2 has rat activity in 30-minute windows. We use a try except block to catch errors in the files around are not found. Let's run this to see the sizes of our dataset. Here we see dataset 1 has 907 landings with 12 columns, and dataset 2 has 23 windows with 7 columns. So we have loaded them correctly. Next, we clean the data to make sure it's ready for analysis. We check for missing values and invalid data like negative times. Let's run this cell. Our output shows only the habit column has 41 missing values, but we are not using it for our main analysis. There are no missing values like key columns like hesitation time or rat minutes, and no negative times, which is great. We also convert the time columns to a datetime format so we can match bat landings to rat activity windows later. Dataset 1. In this cell, we get a quick overview of dataset 1, the bat landings. We calculate the total landings, risk-taking percentage, average hesitation time, and reward rate. We have got 907 landings for 49.5% risk-taking and average hesitation of 11.7 seconds with a spread of 27.6 and a 53.4% reward rate. This tells us bats sometimes take risks and get food about half the time. Behavioral pattern. We look at bat behavior patterns in dataset 1. We group risk-taking and reward rates by season and risk-taking by time after sunset. Let's run it to see the results. Risk-taking is 56.3% in season 0 and 48.1 in season 1, while rewards are 36.4% in season 0 and 56.7% in season 1. Risk taking by night ranges from 41.2% and 55 to 55.4%. Now Shihab will continue from the next part.
So let's jump into the visualization. So here we create three plots for dataset 1 to show our patterns visually. First, a bar plot for risk-taking by season, 56.3% in season 0, 48.1% in season 1. Second, a bar plot for reward rate, 36.4% in season 0, 56.7% in season 1. Third, a box plot for hesitation by risk group. Statistical test. Uh, this tells us bats that avoid risk tend to hesitate significantly longer before approaching food compared to those that take risk. So hesitation is not random. It's linked to risk-taking behavior. Dataset 2, descriptive statistics. So rats are relatively infrequent visitors compared to bats, but their presence could still disrupt bat foraging. And this sets the stage for testing whether bat hesitation or risk taking changes when rats are around. Rat patterns. So Reds show clear seasonal and nightly patterns for activity. They arrive rarely in early months but peak in months 4 to 5, staying up to 4 minutes per 30-minute window on average. By time of night, activity is higher about 8 to 11 hours after sunset, while early hours show much longer, lower presence. This pattern suggests bat face the most competition from rats later in the season and later in the night. Visualization. The first bar chart shows rats arrival uh, by month. Rats appear rarely in early months but steadily increase, peaking around month 5 with nearly 0.75 arrivals per 30-minute window, and this indicates strong seasonal variation in rat activity. The second scatter plot compares bat landing with rat presence. There is a clear negative trend as rats spend more minutes on the platform. The number of bat landing generally decreases. This suggests the rat presence competes with bats for access to food. Bat versus rat comparison, merged datasets. So in this step, we merge the bat landings dataset with the rat activity dataset. To do this, we sort both datasets by time and then use an as of merge, which matches is each bat landing to the most recent rat observation window. After merging, we filter out any landings that don't actually fall inside the 30-minute rat window. This ensures each bat landing is paired with the correct rat activity conditions happening at that time. Correlation. This analysis checks whether bat hesitate longer when rat spend more time on the platform. Using a Pearson correlation, we find a very small positive relationship, which is R equal to 0.09, that statistically significant, which is P equal to 0.0069. This means as a rat presence increases, bat hesitation increases slightly, but the effect is weak. Overall, bat shows mild sensitivity to rat activity, consistent more with competition than strong predator avoidance.
So I'll start from the she-square test, red presence versus bad risk taking. The test looks at whether bad risk taking depends on whether rats are present. A she-square test compares to the two groups, but the result shows x square equal to 0.0000 and the p equal to 1.0000 with identical expected frequencies across cells. This means there is no statistical association between rat presence and bad risk taking. In other words, bats take risks at similar rates regardless of whether rats are around, suggesting competition rather than predator avoidance. T-test. The test compares bat hesitation times between periods of low rat activity and high activity. Using the median number of rat arrivals as a cutoff, the WELK t-test result is t equal to 1.46 and p equal to 0.1439, which is statistically significant. This means bats do not hesitate differently in high rate periods compared to low rate periods. Overall, the evidence suggests bats continue foraging similarly even when rat activity is higher. Scatter plot. This scatter plot shows the relationship between red presence and bed hesitation time. Most data points cluster at low red presence, with hesitation times spread across a wide range. The red regression line slopes slightly upward, reflecting the weak positive correlation found earlier. This suggests that bats hesitate a bit more when rats spend longer on the platform, but the effect is very small. Box plot. This box plot compares bat hesitation time in low red intensity periods versus high intensity periods. These distributions look very similar with wide variation and overlapping ranges. A few outliers show extremely long hesitation, but this occur in both groups. Overall, the visualization supports the statistical test result, but do not show a strong difference in hesitation between low and high rate periods. This test checks whether bats hesitate more immediately after a rat appears. The Pearson correlation is R equal to 0.026 and P equal to 0.4403. which is not significant. This means hesitation time does not depend on how recently a rat arrived, showing no evidence of heightened vigilance right after rat activity. And last conclusion. The results show a weak but significant correlation between rat presence and bat hesitation, suggesting a small increase in caution. However, there is no significant link between at rat presence and bat risk taking. Together, this suggests bat treat as rats more as competitors for food rather than as predators, since there is no strong evidence of avoidance or elevated vigilance. Thank you.